Hey guys, welcome back to my channel. In this video, we are going to solve this very beautiful problem, that is rat in a maze problem. And believe me, this is very easy problem and you will eventually find it that it is very easy. So let's see what this question is asking. It is asking that consider a rat placed at 0, comma 0 position in a square matrix that is name is mat of order n cross n. It has to reach the destination at n minus 1 n minus 1. Find all the possible paths that rat can take to reach from source to destination. Okay, it is given that your rat is at the starting position, and the starting position of rat is 0 comma 0. That is the first like the first point of this matrix, and the ending position is n minus 1 n minus 1 if the square matrix is of size n cross n. So the ending position is this one, that is the what we say bottom right cell, and the starting position is top left cell. Okay, so you have and you can go up to four directions like up, down, left and right. And you have to find the path basically. And one more thing, here it is given value 0 at a cell in the matrix represent that it is blocked. That means if there is 0, that means you can't go to that direction, and if it is 1, that means you can go to that direction. Is It simply means if there is 1, that means you can continue moving on, and if there is 0, consider 0 as a stone placed in your path, so you can't move forward now. So that's why you consider 0 as an obstacle, so you can't cross that 0. So if you encounter 0, you just need to return back from that point. You can't go forward. And if you find 1, you can continue moving on your path. And this is your starting point and this is your ending point. You have to reach this point, and you have to tell how many paths are there to reach from the starting point to end. And one more condition here it is given, like if the path in a path no cell can be visited more than one time. That means if you have visited this one, then you cannot visit this one again. I will explain you what does it means. Then let's come to this. If the source cell is 0, that means if the source cell is 0, that means if this point, that is the starting point, is 0, then the rat cannot move to any other cell. And that is absolutely true. If at the starting point there is a stone, then how can you go reach the end destination? You can't reach. So that's why in this case you just have to return the output as a minus one string. Okay, so let's see how we are going to solve this question. So this is our matrix. Okay, now this is your starting point. This is your starting point. Okay, and you have to reach here. This is your ending point. Let's say this is your starting point, start, and this is your ending point. You have to reach here, and you have to tell how many paths are available. Now let's try to do this question. Okay, you are at the cell 0 comma 0. Okay, if you do you know numbering also 0 1 and 2 and 3, so these are the indices 0 1 2 and 3. Okay, so you are initially at 0 comma 0 location, and you need to reach 3 comma 3 location. You start from here. You can move in all four directions: up, down, left and right. Okay, so let's say can you move upward direction? Can you move from there? Can you move up? Absolutely no. Why? Because if you move up, you will get out of the maze. And if you get out of the maze, that is not considered as a path. You will get out of the maze. So you will never reach the end destination. If you go left, you will again go out of the space. That is the maze space, the matrix. If you go right, then you see there is a stone. That means you can't continue moving forward. So that means you can't go right also. You have explored three directions: up you can't go, right you can't go, left you can't go. Then only one direction is remaining, that is downward. So you move down, you come to this point. Okay, you have visited this cell, you have visited this cell, so mark it as visited. Okay, now you come to this cell, and let's track down the path also. You once you visited down, okay, then you are at this cell, that is 1 comma 0. Now you have all four directions. Either you can move to this point, or you can move to left. Here you can't move left, and you can't move upward also, because if you try to move upward, you will see that if you try to move upward, you will see that you are again coming to a point where you have once visited. And here it is clearly mentioned that where it is like if in a path no cell can be visited more than one time, if you move up from this location 1 comma 0, you will go to location 0 comma 0, but you have already covered this location, so that means you can't move up. So you can't move up, you can't move left, because left is out of this maze space. You can either move to right or either move to down. Let's say I move to the down. Let's say I move to the down. Okay, so I move down. Now I come to this location, that is 2 comma 0. From here again I have three direction. Either I can move left, either I can move right, either I can move up, either I can move down. I know if I move left, it is a boundary. I'm going out of the maze, so I can't move. If I move up, I can't move up, because in the above there is the cell which I have visited, so I can't move there. If I move try to move down, there is an obstacle, that is 0, so I can't move down also. So that means only option remaining for me is to move in the rightward direction. So I will move right. So let's say you move right. Now you come to this location, that is this one. Now you are at this one. You have four choices. Either you can move up, either you can move right, either you can move down, either you can move left. So where you will move? You can move upward. This cell is not visited, that is 1 comma 1 cell is not visited, and you are at 0 2 comma 1. So if you move up, you can move up, but you can't move left, because the left cell is already visited. You can't move right, because in right there is an obstacle, that is 0. Let's say you move down. Let's say you move down. So if you move down, let's say you move down. So if you move down, you will come to uh, this cell. You will come to this cell, and now you again have all four options. You can move up, but you can't move up, because if you move up, you will go to the cell which is visited once again. So you can't move up. If you try to move left, you can't move left, because there is 0. That means an obstacle. If you try to move right, you can move right, or either you can try to move down. If you move down, you will go out of the maze, so you can't move. So you will try to move right. You will try to move in the right. So if you move right, you will be at this location. Now again here are four choices. You can move down. No, you can't move down, because if you go down, then you escape the matrix. And if you move up, there is a if you move up, there is 0, so you can't move up also. If you try to move left, you will come to this location, this cell which is already visited, so you can't move left. If you move right, if you move right, then you will go to this cell, and you can also move right. So you come to this cell, so you move right, and you come to this cell. The point you reach to this cell, that is your ending cell, you have covered one path. So your one path is like DDR, and you can see here, this is DDR, and this is your one path, that is path number one. What could be the other path? Let's see what could be the other path. So let's remove all of this. You have covered one path, okay. So our path was D, D, R, D, R and R. So see, when you were at let me remove this. Okay, Okay, now let's see. Yeah, now now you have covered. Initially you were at this point, you move down, you move down. Okay, then you come to this location. In earlier in earlier path, you move again down, so then you come to this location, that is 2 comma 0. But you are also having a choice to move right, so let's try to move right this time. So if you try to move right this time, you will come to this location, that is 1 comma 1. So you move right, and from this you can go in all four directions. If you move up, you will encounter a 0, that is you can't move there. If you move left, you've already visited that cell, so you can't move left. Either you can move right, but you can't move right also because there is 0. So you can move only in downward direction, so you go there. So you move down, you move down, then you come to this location. Here again, all four choices, either to move left, either to move left, either to move right, down or up. You can't move up because you have already visited. You can't move right because there is a 0. You can move left, you can move left. Okay, and you can move down. Let's suppose we go to down. So we go down, we come to this place. Here it have all four choices. It can move left, it can move right, it can move down, it can move up. It can't move left because at left we have 0. It can't move down because if we go down, we escape the matrix. You can't move up because if you move up, you will come again to a cell which is already visited. You can only move to right. So you move right, you move right, and then you will come to at this point. Now here you have four direction: either move down, either move up, either move left, or either move right. You can't move up from here because in the above there is a cell which is containing 0, that means an obstacle, and you can't move forward from there. So you can't move up, you can't move left, because if you go left you will come to this cell which is already visited, so that is not possible here, because it is already told that in a path no cell can be visited more than one time. Okay, so you can't move up and left. So if you try to move down, you can't move down because if you move down you will escape the matrix. So that the only option left is to move right. So you move right. If you move right, you will come to this cell, and this is your ending cell. This is your ending cell, and you have find the another path also. So this was path number 1, this was path number 2, and this is the path number 2, d r double d r r d r double d r r. So this is how you are going to do this. So if you see that what will be the time complexity for this, what will be the time complexity for this? Time complexity will be your you will traverse the matrix which will be taking n cross n time, n square, and you are moving in all four direction. So basically it will be like 4 raised to the power n square every time you are traversing the whole matrix, and you're taking all four directions. So it is 4 raised to the power n square. Okay, so let's see how we are going to do this problem. Let me remove this. Okay, now let's see how we are going to do this problem. Okay, so let's try to code this problem. So here in this problem, we have to return a vector of a string. So let's create a vector of type string. Let's name it as answer. Then it is return one thing, that if the source cell is 0, the rat cannot move to any other cell. In this case, no path. In case no, there is no path, and you have to return an empty list. The driver output will run for that this minus 1. So what you have to do this, like if matrix of 0 comma 0, that means the starting point of the matrix, if it is 0, then you have to return what? Vector of a string of uh, string is of minus 1. Okay, then now let's call the solve function which is going to solve, and the starting position is 0 comma 0, that is this. And apart from it, I'm also passing a matrix because I have to traverse the matrix. Then I'm passing an empty string which will be containing my answer. Okay, and then and then we will pass this answer vector. Okay, and then I will just return this answer. So let make it a big so that you can it will be visible to you. Now let's call this solve function. So it is of void type. So it is having few things like int I, int j, the locations. Then it is having the metrics. So let's copy it, let's paste it here. And then we are having a string also. So let's say the string name is s, and then we are having a vector of type string. I'm passing it by reference, and we have answer. So now we know that what will be the base case. What will be the base case? Base case will be when will we reach to the end location. End location is when we will reach to n minus 1, n minus 1, that is to this location. So that means if my I is equals to n minus 1, that is matrix dot size minus 1. So this is my row. I is denoting the number of rows and j is denoting the number of columns. That is basically I is denoting the ith row or jth column, and j is denoting the jth column. So if I becomes equals to the last row and j becomes equals to the last column, so how we find column? Like matrix dot of 0 dot size and minus 1. So if I comes to at the last location and j also comes to last location, that means we are reach the end destination. So when we reach the end destination, what we are going to do? We will just push our string which we have made till now in our answer vector, and we will return from there. So this was our base case. Now we have some other cases also, like when our path was invalid. So invalid locations, LOCAT locations. What will be the invalid location? If if I is less than 0, similarly if j is less than 0, similarly similarly like I is less than 0 means, let's say I is at here, so it is 0. If I is less than 0, that means I will come to here, that is at minus 1. So that is the out, so that means it is going out of the maze, out of the matrix. So we don't want that location, we don't want to go in that location. Similarly, if j is less than 0, that it is moving, going out of the matrix. And similarly, if I is greater than equals to matrix dot size, that means let's say I is going in the downward direction and it escaped this 0 also, so that means it is going out from the matrix. And or so these all are in the or conditions. If j is greater than equals to matrix of 0 dot size. Okay, and one more condition will be what? Can you assume? Yes, if you assume this, then that means you are on the correct path. If you're not, sorry, it is not a grid, it is matrix. If your matrix of ij is having 0 at that location, that means there is an obstacle, you can't move. So there are few conditions when you can't move. Either you are moving out of the matrix, so these are all denoting the out of the matrix, or or you are you are at a location where there is 0, that means there is an obstacle, so you can't move in forward. So what you will do, if there is anything in this case, anything uh, these cases occur, you will just return from there. So you have invalid location, you have base case. Now what is remaining? The remaining part is to traverse the matrix, that means to go in all four directions. But before going in all four direction, what we were doing, if you see uh, like if you see this matrix, you will see that when you were at, let's say, uh, when you were at this point, you mark it as visited, then you come to this point, you mark it as visited, then you come to this point, you mark it as visited. Now let's suppose you reach the end here. Let's suppose this is the only end and you reach here. So when you have made all four call for this, you have to unmark this also. You have to then unmark this also, unmark this also, so that these path can also be visited by some other cells. That simply means uh, like you are taking this path initially, this path to reach the end. So you have marked these cells as visited. Okay, But there is also one more path which is like this, which is like this, which is like this. Okay, which is was this was the second path, this was the first path. So what I'm trying to tell you that once you visited this cell and you have made all four calls, you have to again unvisit this cell, you have to unmark this cell. So you can do this by two things. uh, First method is to make changes in this matrix only. That means you are at matrix of 0 comma 0. uh, Initially it was 1, so we'll mark it as 0, and then you will make all four calls. So initially, let's suppose I'm going in upward direction. That means I minus 1, j will remain at its position. I'm passing matrix. In string, I'm adding up because I'm going in upward direction. So I will add u, and I'm passing the answer. So this is for up, and I will copy paste this whole thing one more time and one more time. So this was up, and if I'm going down, I will doing I plus 1, and j will be at in its position. So I will do d. That means I'm going uh, down. If I'm going left, that means I will remain at its in its position, only j will move, so j plus 1. Right means we are going in this direction, so j is incrementing. And if I'm moving left, I will remain same in its position, and only j will move to in the leftward direction. That means decrement. And this was right. So we have made all four calls. When all four calls will be made, we will again make this change, revert back this change. We have changed our cell to 0. That means we have visited. Then unmark this change also. Unmark this. Unmark. Unmark this change for other calls. Other calls. So let's see if this works fine or not. Let's run this. So it is running. It is giving error, some errors. Okay, we have some output differences. Okay, we have not included right path, so we are moving right direction, so it will be right, and we are moving left direction, so it will be left. Okay, now let's compile this. I hope so this will work fine this time. Yes, this is working. Now let's submit this code and see what will be our output. Yes, we have passed all the test cases. So this was our question. The time complexity is of 4 raised to the power n square, and the space complexity will be O of, uh, let's suppose the size of the average length of the string is, let's say, L, and we have X number of data strings. So space complexity will be L into X, where L is average length of the string, leng length of the strng string. So hope so you find this solution useful. If you have any doubt, you can tell me in the comment section. I will try to resolve your issue. So tab tak ke liye, take care, bye bye, see you in the next video.